Entity properties. That's a pretty big topic. I could just begin by listing all Half-Life entity properties, but nah, you know me. Let's take a couple of steps back and ask ourselves, what makes a game entity? Seriously, what's a game entity made of in Half-Life? Surely, each entity has a position in the world and an orientation. Entities can have models so the player can see them. They have names as well so we can trigger them. They have render mode, render effects, render mount, you get the point. A single entity can store relatively a lot of data. Some entities like Functor have custom properties like lip, rotation angle, and so on. Implementing that will be in the next video. For now, let's just focus on the variables common to all game entities. I'll only briefly mention and explain some of the more important ones. PEV origin is the position of the entity in the world. Not much to say here other than Z being up, X being forward, and Y being left. One thing to note about the origin is that it's limited to an absolute value of 4096 in each axis and 8192 for players. This is determined by delta LST. PEV angle is the entity's orientation in Euler angles, also in world coordinates. One important thing about angles is that brushes and studio models have different interpretations of pitch. What I mean is, if you set it to 30 degrees, a brush model would rotate downwards while a studio model would rotate upwards. If you're having trouble wrapping your head around this, watch this. Let's take yaw as an example. In Quake and Half-Life, yaw is the rotation about the Z-axis. You can imagine it as some sort of invisible spear that stabs the entity, and by rotating itself, it rotates the entity too. Now, remember how I said that Z is up? Well, yaw by definition is the rotation about the up axis, at least I think. Pitch is the rotation about the side axis, in this case the left one, and roll is about the front axis. The roll of XYZ is different in most engines. For example, Y is up in Unity. So in Unity, yaw would be the rotation about the y-axis. The point is, it's easier to understand these angles if you think about rotations about forward, up, and right instead of rotations about x, y, and z. Because x, y, and z are used for different things in different coordinate systems. You got the left-handed one, right-handed one, and various variations of them. Now, PEV velocity is the entity's velocity in units per second. It is limited by svmax velocity, which is 2000 by default, but it can be absurdly high if you want to simulate bullets or something like that. PEV-A velocity is the same deal as velocity except it updates angles instead. It means angular velocity. PEV target name is the entity's name specified by the mapper. You can use it to print warnings into the console in case a mapper uses your entity incorrectly. PEV target is the entity's target field, also specified by the mapper. You can use it to find other entities, which we'll cover in an upcoming video. PEV model is the path to the model, usually specified by the mapper. This one is practically read-only, because there's no purpose in setting it. You can set it, but it's not going to have an effect. You typically read it if you're working with entities that can support custom models. PEV maxes and PEV mins are the dimensions of the entity's bounding box. It has an absolute variant as well, PEV absmax and PEV absmin. These are used for various things like determining the center of a brush entity without origin brushes or collision. The bounding box is axis aligned, which means it cannot rotate. PEV solid is the type of solidity for this entity. Solid nod means the entity will be completely passed through. Solid trigger means the entity will still be passed through, but touch will be called when an entity touches it. Solid B-box and solid slide box are about the same. They use the bounding box of the entity for collisions. Solid BSP finally uses the brush model's clip nodes for collision. PEV effects is a sometimes very useful little variable where you can enable special effects, such as bright light which emits a huge light around the entity, dim light which emits a smaller light instead, inv light which tells the engine to sample lighting from the ceiling instead of the floor, which is used by barnacles, it means inverse light, light which emits a light but also renders an animated rocket flare sprite, and no draw which basically prevents the entity from rendering. Now, for the end, I'm going to list one which is specific to players, but it's extremely useful. That would be PEV button. It basically stores what buttons the player is holding. With it, you can detect if the player is trying to move, use, attack, reload, crouch, and so on. You can do a lot of cool stuff with it. For example, you could do vehicles. We'll see the others in future videos as we work on more specific stuff. And that's about it. In the next... Oh, right. Precaching is also in the title. Precaching is basically loading certain assets into memory before they can be used. You can precache models, sounds, and generic files. The individual file size limit is 16 megabytes. So let's see what would happen if we tried to set a model on our entity without precaching it first. In order to precache it, we can simply add precache model into the spawn method. Obviously, the model path has to be the same. Anyway, one little detail. In the SDK, entity classes typically define a precache method, which, however, is called from spawn. It's a bit of a weird design, and it probably would have been much better if precache was dispatched, just like SpawnThink and others. But alas, Valve made many illogical decisions while developing Half-Life. So did I with this tutorial series, but let's not get too carried away. Now finally, let's write an entity that makes use of what we've seen so far. Let's write our own prop entity. The idea is the mapper is going to set the model, and whenever the entity is triggered, it's going to hide or unhide itself. We also gotta remember the fact that all uninitialized PEV variables are 0. Quake does a mem set on them while spawning the entity. We could also prove it experimentally, but see for yourself. The point is, if PEV model is 0, that means the mapper didn't set the key value, so it's going to be invisible. So if the entity is invisible from the start and doesn't know which model to use, it serves no purpose, so it should be removed. Thus, in the spawn method, we'll remove the entity if it doesn't have a model. However, if it does have a model, we're going to precache it and set it. And finally, we set the move type and solidity. Alternatively, you could use solid B box because set model determines the bounding box from the given model. How do I know? As usual, you can just look at the Quake source code. In the use method, we'll basically flip the EF no draw effect flag, using a simple XOR operation. Now we can write stuff for the FGD, and test the entity. Also, for the fun of it, let's write an entity that follows the player and emits a bright light. We can use PEV velocity for the following, and PEV effects for the bright light. In the think method, we'll find the player. We know for sure that the player is pretty much the very first entity in single player. Then we'll just figure out the direction and distance between this entity and the player and set that as the velocity. Now, in spawn, we'll precache and set a sprite as the entity's model, then set PEV effects to bright light. Also, set the render mode and render amount. Render mode should be additive so we can see behind the sprite, and render amount can be anything visible like 255. Oh, right. And that's about it for now. In the next part, we'll do custom key value parsing and how to save and restore variables. Until then, happy programming!